We're going to try and create a new product using the products that we've taken apart. We're going to look at the innovation process, brainstorming, and then try and solve some of the initial problems that we face in making these products work together. So this is a little digital recorder I got at Radio Shack, and you can see there's the hairdryer there, and we got a tap light right here. And the tap light's just, a battery-powered LED light, and then we got our zip ties, and you can see the digital camera and the alarm clock, and we're trying to find ways to make these work together and do something useful for us. So we're going to take out our sketch pad and start drawing out different concepts that we might be able to make with these things. So the tap light, I like the dimensions of the tap light, so I'm going to try that first. And we're going to use the hairdryer has motors, so we know the motors can blow the tap light or potentially move something. So we're sketching a tap light with hairdryer motors on it that could blow it around and make it move. And maybe we'll use the body of the alarm clock to create a little bot that drives around. We need some wheels for that. And again, we might be able to use the hairdryer motors or maybe the DVD player motors. So I'm interested in creating something with a personality that can move around, something that is able to respond to its environment, and can use the products that we've already disassembled to make something new. Hopefully, maybe it can take pictures and maybe record some sounds and play those sounds. Okay, now that we have our objectives, how do we make it work? So what we're going to do is let's just isolate each one. To move around, we can use the hairdryer motor. And we know that moves, and we could use two of them and maybe use them to blow air to move our device. Or we could turn a wheel with them. And to interact with the environment, we need some sort of switch or sensor. So we maybe could use the switches from the alarm clock so that if it hits a wall or something, it can back up and turn around. And we can use our camera and sound card to record images and sound. But how do we control all of these things? Well, we're going to need a microcontroller, and we've selected a microcontroller, and we've got our camera and our sound card, and our motors from our hairdryer, and then of course we have our tap light, and we probably could use the tap light as our body to put everything together in. And we need something to power all this. We need batteries. One of the first issues we're going to run into is that we think the motors run on 12 volts. We know that the sound card runs on 9 volts because that's the kind of battery it needs, and the camera takes 4.5 volts, and the microcontroller or Arduino takes 5 volts. So everything's running on different voltages, and we have to find a way to control all of those voltages and get everything to work together. So we can do that with a motor controller. The motor controller will provide different voltages for us to run on and allow us to run our high current, high voltage motors with and control them with our low power, low current, low voltage Arduino. So that's why we need the motor controller, and we go into more detail on that in the motor controller video. So let's get started taking our hairdryer motor apart, and are taking it out of the hairdryer, I should say. And since that's going to be what we're using to move our craft around, we want to start to experiment with it and see how much power it's going to require and how much torque it's going to have and things like that. Alright, so we're going to experiment with our motor and see what it's going to take to power it. We got our alligator clips connected, and we're going to use a 1.5 volt AA battery to see if we can make the motor turn and to kind of get a sense for how much air it will pull through it at 1.5 volts. So we've got a little piece of plastic here to test the motor. So we're running it and we're holding the plastic up, and you can see it's not moving the plastic at all. So that's not going to work. We're going to need more volts than that, and we can increase the voltage by combining the cells in a battery holder, and that allows us to wire the cells in series. So we go from 1.5 volts to over 12 volts because those cells are new. So let's see what impact that has on the motor. Okay, so we're connecting our battery to our hairdryer motor, and whoa, you can see it's moving much more quickly now. Now it'll push the plastic completely out of the way, and we're getting a fair amount of air coming out of it. But I don't think we're going to use this method for moving our craft, because even though it's blowing a fair amount of air, it only works really efficiently in one direction. In the other direction, it doesn't work as well because it's only meant to blow air in one direction out of the hairdryer. Okay, so let's determine the actual specs for our motor so we know exactly what we can run it on and how much voltage it needs. To do that, we're going to need to remove the propeller and the outer housing around the motor. So we're just going to trim that off with our hacksaw there. And we're time-lapsing this so you don't have to sit through all of it. But in any case, we're going to trim the propeller off. And then it's a really tough thing to get off because it's friction fitted onto this brass fitting on the end of the motor. And so it's really hard. They definitely did a good job of press fitting that onto the brass fitting so that it won't come off as the hairdryer moves around. So we're taking our nipper pliers here and we're just going to trim the rest of the propeller off so we can get to the motor, and we'll move the end of it off there and then unscrew the last two screws and slide the ends off. And then we'll take a look at our spec. Okay, we've got our motor here. Let's flip it around, see if we can find the specifications on it. And yeah, there's some printed text right here. Okay, so we can type that printed text into the computer and determine what kind of motor this is and what the specifications are. So it's always good to type in the actual name of what you're looking for when you type in your part list there. So we've got a Kaizen specification sheet. This is actually a Mabuchi motor. And we'll go through and we'll see if we can find it. It's right there, the 2073 model. So our operating voltage is between 9 and 24 volts. Nominal voltage is around 20. With no load, the motor will spin at 17,200 RPM, which is very fast, at a current of 0.2 amps. And we're always going to be operating under load, so we'll always be pulling more than 0.2 amps. The speed of the motor can, at maximum efficiency is around 14,420, and then we've got a current at that speed of around 1 amp, and that's under load. And then the torque is 9.49 Newton meters or 96.7 gram centimeters. And that's the twisting force that the motor can generate. And so that's an important number to know. It does look like that's going to be enough to move our craft around since it's not going to be very heavy. And then the motor can generate an output of 14.3 watts. So what's the key number that we need to take out of this chart is the voltage. We need to make sure that we're operating within the voltage envelope that the motor can run on. And if we use our batteries together in series, like we did when we were testing it, we can operate at around 12 volts, which is between the 9 and 24 volt range and should be fine for us to run at. Now we're going to control the speed of the motor using our Arduino and our motor controller. So the Arduino is going to send what's called pulse width modulation to the motor, and that's going to change the speed, make the motor run much more slowly than it would if it was just running with straight current.